the graph of this curve at this point. And of course, we have to start by applying this operator, the differentiation operator, to both sides. And what do we get on the left? Yes, indeed. Careful now. Put minus, and let's use parentheses. The first function prime.
1
times the second one plus the first one times the second function prime.
Which is dy over dx.
Thank you very much. We are here now. Minus y squared prime.
That would be 2y times dy over x.
Excellent. Equals 1 prime. I know you're going to say 0. Not yet. Not ready. We have to distribute. The reason why I prefer to keep it outside is because we may forget to put the negative here, and then the whole thing collapses. So I have 2x minus y minus x dy over dx minus 2y dy over dx equals 0.
Can you pause for a second?
Sure.
Can you go back to the previous line? So I'm good with the 2x and then minus.
It's the product rule. Product rule.
So we add x plus y, or y plus x. Okay.
So the first function prime is 1 times the second one plus the first function times the second one prime.
Oh, okay. Okay.
Minus 2 times y times dy over dx equals 0. I'm going to keep these here. I'm going to move these to the other side. So 2x minus y equals, they are both negative. So x plus 2y. In this process, I already factor out their common factor because I cannot add them or subtract, whatever you want to say, it doesn't matter. So I'm moving them to the other side, they become positive, and right away I factor out dy over dx. So then, now I want dy over dx, and then I'll plug in what I need to plug in. So, dy over dx. It's the opposite.
It's going to be equal to
Yes. It's
dy over dx is going to be equal to 2x minus y.
over what multiplies. This is the factor, yes. X plus 2y.
X plus 2y.
Perfect. And now I have that x is 2 and y is 1. And I can continue. See, this becomes a little bit cumbersome because I don't have anywhere to plug in those numbers. So I have to write a vertical line and on the side write these numbers. So 2 times 2 is 4. 4 minus 1. 2 plus 2 times 1. So the numerator is 3, the denominator is 4. So I have y minus y1 equals 3 over 4 x minus x1, where x1 is 2 and y1 is 1. So I have y minus 1 equals 3/4 x minus 2. Or y equals 3/4 x. Now I multiply. Remember, 3 over 4 by 2 over 1, and I simplify. And that's how I get minus 3 over 2 and plus 1. So negative 3 plus 2 will be negative 1. So this is negative 1/2, 3/4 x, and this is y. What does this represent? Is the equation of the tangent line to the graph of this curve at this point. Any questions? Any questions? How do I feel about implicit differentiation and finding equations of the tangent and plugging in the formula? How do I feel about that?
I feel okay now that we've done a couple practices with both, so I feel
Sure.
better when we first did.
Sure, and once you work on these problems again and do some web assigned problems, you can come back with other problems or other questions. Absolutely. Nothing comes easy till we practice. Awesome. Okay. I promise you the last formulas in 3.6. We're going to talk about log. And inverse trig. I'll start with this, with the inverse trig. And their derivatives, of course, that's what we're discussing. We know that sine x prime is cosine x. But sine has an inverse function. Sine inverse x. Inverse sine function. Okay. This does not mean 1 over sine x. No. Sine to power -1 does not mean 1 over sine. And I can show it to you in the graphing calculator as well. So see the sine, cosine, and tangent, the direct functions. Here they are the inverse functions, and they're activated with second function, right? Second sine. This does not mean 1 over sine. It means the inverse function of sine. Same thing here. Second and cosine. It does not mean 1 over cosine. It means the inverse function of cosine. And the last one that we have in the calculator is tangent inverse. So these three inverse functions. That's what we're going to focus on, these three. Okay, now, so when we differentiate sine inverse, I'm on page 13. So when we differentiate sine inverse, please do not say bring -1 in front and subtract 1 from the power, because this is something else. Then we have 1 over the square root of 1 minus x squared. So we have to add this to the long list of formulas. And we're going to add the other two. So cosine prime, as we know, is negative sine x. But cosine inverse prime, again, is not -1 and cosine to -2 and blah, blah, blah. No, it's the same formula, but with minus in front. Very easy to remember. And the last one, tangent prime, as we know, is secant squared. But tangent inverse prime is 1 over 1 plus x squared. So the derivative of the inverse function of tangent is 1 over 1 plus x squared. And of course, if we don't have plane x, here's an example. Tangent inverse of x to the third. How do I differentiate this? Here's the formula. Tell me, what would you write? Please talk to me when it's okay if you're wrong. It's okay if you're wrong.
I'm guessing probably 1 over 1 plus x to the power 3 to the power 2. So it'll be power 6.
Yes. Times the inner function prime.
Should be tangent x to the
Inner
or
inner function.
3x squared.
That's it.
Yeah.
3x squared. Yeah.
This was the outer. We already did what we needed to do, and this is the inner. So the final answer is 3x squared over 1 plus x to the 6th power. Awesome. Great job. Let's focus on this for a moment. Where is my book? Where is my book? Don't choose natural log yet. We haven't discussed this yet. I want to practice a little bit of inverse trig functions. Here they are. Only sine, cosine, and tangent. I don't need secant. Nothing wrong with it. But I want to practice the main ones. Sine, cosine, and tangent. Anything you want from 63 to 78 with sine, cosine, and tangent. Inverse sine, inverse cosine, inverse tangent.
Which has 67.
67. Perfect. Awesome. Let's look at 67. Y equals tangent inverse squared. Perfect. So y prime. This is the inner. This is the outer. We start with the outer. So we differentiate the outer. Anyone, please? You have to say 2 tangent inverse x to 2 minus 1 times the inner function prime. What is the inner function prime?
1 over 1 plus x squared.
That's it. Done. If you want to condense it, that's it. Great job. Any questions? Okay, next question, please. Let's take a look. Yes, one thing I wanted to mention. When I type up a test, I prefer to write arc sine x. This is the same thing, it's a different way of writing sine inverse x. I think that this notation is a little confusing. I prefer this one. Also, it's easier for me to type this versus putting the power. So they are the same. Arc cosine x is this, is the same thing with cosine inverse, and of course arc tangent x is the same thing with tangent inverse x. Again, I feel that this is a little bit confusing. I prefer this notation. They are the same. Yes. We cannot choose 69 just yet. We will, or 70. But we can use, we can look at 71. We can look at 72. Forget this. It's okay. We can look at arc sine 1 over t, and so on and so forth.
Can we do 74?
Yes, 74. So r of t equals arc sine 1 over t. Perfect. So we want to differentiate this. R prime of t. Outer, inner. Outer, inner. So, that's not a good color. Yes, I'm ready.
Would it be 1 over the square root of 1 minus x squared? Sorry. 1 over, sorry, t. Squared
Yes. Times
times
the inner function prime. And we did that many times in the past. It's an important formula. We have to know it.
1/2, or sorry, 1 over,
Nope. Yes. We have, this is a very important formula. It's negative 1 over t squared. This is super important. So you can leave it as is, or try to simplify a little bit in parentheses. So I have negative 1 over t squared. Then I have here the square root of t squared minus 1 divided by the square root of t squared, assuming everything is okay. Then I can further simplify it into this under certain conditions, right? Very good. Any questions? Okay, do we feel like working on other problems? Um, 76 is interesting. Let's look at 76. Y equals cosine inverse of sine inverse of t. So we want to find y prime, or if you want dy over dx, it doesn't matter. Outer, inner. Outer, inner. If you don't like it like this, you can write it as arc cosine of arc sine t. It's up to you. Arc cosine, arc sine. Arc cosine of arc sine. So we differentiate cosine inverse or arc cosine of this. So what do I have to write? The derivative of cosine inverse. What does it mean?
-1 over the square root of 1 minus x squared.
The square root of 1 minus this. This is not x squared.
Yeah, sorry.
This is the argument. So this is what we have to square. This. So sine inverse t. Oh, sorry. It's t, not x. Good. Times the inner function prime. The inner function prime.
Minus
1 over the square root of 1 minus t squared.
That's it. That's it. And you don't have to do anything else here.